Okay, welcome people to our introductory lecture about descriptives. So here we are just going to get a little bit introduction about descriptives. Here we again have the same data set: anxiety, burnout, and then rollover load. So what actually, how are we going to get different mean standard deviation for our variables? We just have to know that what first step you actually have to perform to get the descriptives. Before getting descriptives, what you actually have to do, you have to compute the variables, each of the variables. So how to compute them? You don't have to compute the item that you have deleted. Anxiety 4 item we had deleted in our previous, because it had deleting it gave us the real reliability that we needed, that was points greater than 0.6. So you're not going to compute anxiety 4th item that in the computation. So before performing descriptives, what you actually need is you actually need to compute all your variables, because descriptives are performed on variables, not on items. So let's begin and perform our computation process, and then go to transform and then compute. This is again transform and compute variable. So back, compute variable. So okay, before moving forward, let's take a look at what items we had deleted. So you can just keep that on right side on your side and just to take a look, because if this is how you're going to perform descriptives are descriptives, and then come down. So this is actually needs a variable. It does not need your item. These are your items. It requires a variable. So what you have to do, you have to perform the computation process and compute all your items in the form of a variable. So close this window, and then just look at a little bit introduction. Descriptives command to get measures of central tendency and variability. So normality. Okay, normality we have added over here. I'll let you know what actually normality is. So descriptives tell us about central tendency and variability. Variability actually tells us about the spread of dispersion of the scores, that how much differentiation is between our scores. So if all the scores are same, there is no variability. Of course, if all are same, then there is no differentiation between the scores, so there exists no variability. If the scores are all different and they're spaced apart, their variability will be high. So the range highest minus lowest score is the crudest measure of variability, but does give an indication of the spread in scores if they are ordered. So what actually variability is, it just tells you about differentiation among the scores. Next is standard deviation. What actually standard deviation is? Standard deviation is the most common measure of variability. So it actually tells you that for measuring variability, we measure standard deviation. Standard deviation is our differentiation from the mean, as you must already be knowing, because this is actually the concept of statistics. So it's what actually standard deviation does. So standard deviation is the measure of variability, and it is if it has normally distributed data, and it is based on deviation of each score from the mean of all the scores. As I've already told you before, that it is actually a difference from the mean. This is the formula for measuring standard deviation, but we don't need it since SPSS runs it by all itself. Then comes the normality analysis. To check if data is normal, normality analysis is conducted. As the name indicates, normality, that this is to check the normality of data. For this purpose, what we do, we conduct normality analysis, and we click on skewness and kurtosis. Skewness and kurtosis give us the normality analysis. The range should be, for skewness, should be between -1 to +1, and for kurtosis -3 to +3. But there are some who say that for skewness and kurtosis, so let's make it for kurtosis are analyzed, because we are going to analyze both skewness and kurtosis. So skewness -1 to +1, and then for kurtosis -3 to +3. And then there are some who say that both can be, if lying between -3 to +3, can be accepted. So let's take a look at the table. This is how we are going to construct the table for descriptives. Here is mean, then standard deviation, then skewness and kurtosis. So this gives us the about detail about our descriptives and how we're going to get it. So I'll be telling you this in next lecture, that how we're going to perform descriptive analysis and normality analysis.